All right, so we've been learning about circuits. What does circuit sound like, Elijah? Circle. So we've been learning about circle. What do you know about circuits? Give me some information about a circuit. What did you learn about a circuit, Michael?
To make a complete circuit, everybody have to do, like to make a human circuit, everybody have to hold hands.
So we got to be on a complete path. We got to be on a complete path. Stand up. What else did you learn about a circuit? Grab hands. Everybody grab hands. It's our lab day. 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 So we are holding hands and we have created a circle. So now I'm going to put my energy stick in and make a circuit. Grab it. Somebody's not holding hands. Somebody is an insulator because I don't hear any energy. Oh, now we have the energy. The circuit is moving because all of the electricity is moving through our bodies. So we have a circuit. Break the circuit, Shaylee and May. There's no more energy. The circuit is open. The circuit is open. Close the circuit. Now I have energy again because the circuit is closed. Jaleesa and Versi, open the circuit. Open it. Circuit is open. Any energy? No energy. Close the circuit. There we go. Now we have energy again. All right. All right, let's go. Come around. Let me move. I was standing by her. Let me come on this side. Grab hands. Grab hands. I have energy. Wait a minute. Oh, that circuit was open. Now the circuit is closed. Break the circuit. Oh, circuit is broken. No energy. Close the circuit. There go the energy again. The circuit is closed. Get ready. We're going to make our own circuits. Let's go. Find your seats. Let's go. We're going to make our own circuit today. If you are a captain, underneath your lab kits, I need you to go get a tray. Just a tray, not the kit, just a tray. Every group, go get your tray. Bring the tray. All right, so captains, look at your trays. Captains should all look at the trays. What do I need to make a circuit? Raise your hand and tell me some things that we need off this tray to make our circuit. Shaylee.
A wire.
We're going to need wires. Actually, we're going to need how many wires?
2.
We're going to need 2 wires. Captains, get 2 wires. Get 2 wires. All right? What else we going to need to make our circuit?
Battery.
We need battery. We need a battery. Captain, get a battery. Okay. But what else I'm going to need? Because I need battery gives me a type of energy. What type of energy a battery is going to give me?
Light.
No, not light. What type of energy a battery is going to give me?
Electrical.
No, not quite. What kind of energy a battery? Chemical. A battery is going to give me chemical energy. But Ms. Carter said we're making circuits and electricity goes through circuits. So how come I got a battery but I want electricity? We've been learning this week about the movie Robots Go from Transformers. So what is going to happen to that chemical energy? Thank you for raising your hand, Elijah. Good job. It's going to transform into electrical energy. So the battery, which is chemical energy, is going to transform into electrical energy. So to create our circuit, inside your on your lab tray, there should be a battery holder. Captains, get your battery holder. If you look on your battery holder, we know a battery has 2 parts on it. What's 2 parts that we know or learned about a battery? We have a positive side and we have a negative side. So we're going to insert our battery in our battery holder. And the positive must be with the positive and the negative with the negative. Go ahead and insert your battery. Positive with the positive. Find the positive first. You see that little plus sign in there? Where's the plus sign on the battery? And you got to open it up and slide it in there. Good job. Perfect. You got to open it up a little bit. Where's the positive side? Show me the positive side.
Right
Now, where's the
there.
positive side on the battery?
Right here.
Okay, now make sure it's lined up though. Positive and positive. You got to open it up a little bit. Positive and a positive. All right, so now that I have my battery inside my battery holder, now I need my wires. What happened with the wires on the circuit? What's going to happen with the wires on the circuit? Tristan, what do I need to do with the wires on the circuit?
You need to connect one side of the wire to the positive and then the other side to the negative.
All right, so on your battery holder, you have two different parts. One side on your battery. Look up here. On one side of my battery, there is one end, and on the second side, there's another end. So you're going to make sure one wire is on the positive end and one wire is on the negative end. I have alligator clips connected so that you can easily pinch them and connect them to the ends of the battery holder. Well, you shoulder partner together and you do the other one. You two shoulder partner together and do the other one. Come shoulder partner with her while she's working on that. No, the clip, just the clip part. Clip it on the end, the metal part. The battery holder has a metal part on it. Why is that metal part you think is on the battery holder, Jennifer? You're gonna punch, you're gonna. Why do you think that metal part? The battery compartment is plastic, but there's a metal part on the end. Why is that? Why do you think is that metal part there?
I think it's because it has energy in it.
Do you think a metal part has energy in it? Elijah?
Electricity can pass through it.
And what do we call those items that electricity can pass through it?
It's electrons.
Not electrons. Electricity is the passing of electrons. What did we call those when the items actually allow electricity to easily pass through it? Tristan?
Conductor.
Conductors. Those are conductors. Only now the second wire. Stop. The second wire. Are you the captain? Then why are you handling that? Who's the captain? You should be doing this. The second wire. This is one wire. How many wires should we have to make a circuit?
2.
You should have 2 wires. So the second wire is going to go from the other end or the negative end. One wire goes from the positive end, and the second wire is going to go on the negative end. I'm coming around. Use this one. Okay, now, but is my circuit complete? No, sir. That's not how we do a circuit. What is missing from my circuit once you have your 2 wires? Oh, because that was what's going through there? Electricity. So listen to directions. Make sure you have 1 wire on the negative end and 1 wire on the positive end. Be on his thing. Y'all 2 partner together and do this one. It's only one of them. Never mind. It's only one over there. Now do this. This is only 1 wire. So now you need a second wire. All right. Once you have your wires connected, raise your hand. Give me a thumbs up. Miss Carter, I got this.
I got this.
You got your 2 wires? All right. Next, you should find a bulb holder, a light bulb holder. Take the light bulb holder. On the light bulb holder, you should have 2 wires coming out of your light bulb holder. This is the light bulb holder.
Oh, it's different.
It's a light bulb. There are 2 wires coming out of the light bulb holder. Look up here. Here's my light bulb holder. At the end of the white light bulb holder, there is a little piece of wire. Good eyes, Casey. Good eyes, looking up there. Good eyes. I'm going to take one end of my clip and I'm going to connect it to the one end of the wire. And the second wire, I'm going to connect it to the other end of this light or lamp. Okay, you need a light bulb holder. When you make your circuit, if I know my circuit is working, my light should come on. If your light came on, give me a thumbs up. Miss Carter, I got this. Your light came on? Good. Give me a minute. Oh, you need a bulb. You don't have a bulb for it. Just making sure that it's connecting the wires together. Unconnect. Yes, sir.
So if you connect these two together, it creates heat, but if you connect it to the wires, it creates electricity.
It's going to collect electricity because of the battery.
Yeah, it was oxygen.
Gotta hold it. That's why the elevator cook gotta hold it. Make sure that it's not on the plastic. If it's on the plastic, what's gonna happen to your electricity?
It's going to become an insulator.
It's gonna become insulated because plastic is an
Insulator.
insulator. So you're not gonna have that light coming on. When your light is on, give me a thumbs up. Miss Carter, I got this.
I was trying to open it.
I can help. Now, do you see a loop? Do you see your circuit is a circle? Yep. Show me your circuit. Show me your circle as a circle. It's on the plastic, darling. It cannot be on the plastic because if it's on the plastic, it's not going to light up. It has to be on the metal. Good job. Let me see. Is it on the plastic? Make sure it's not on the plastic. See, it's on the plastic. It can't be on the plastic. It has to be all the way on the wire. Only the wire. No plastic. Because plastic is an insulator. All right, now, on your sheet, look at your lab sheet. Touch your lab sheet. On the first thing, what's the first thing? Let's read the directions. Class?
Yes.
Get ready, read. Draw a picture of the closed circuit you created. Label the parts. Let's go. Draw your circuit. Label the parts. What parts do we need to make our circuit? Give me one of the parts we needed, Elijah Nelson. What's a part we needed that you're going to label?
The wires.
Wires. What's another part that you're going to need to label, Tristan? Battery. What's another part that we're going to use to label? Let's see. It was working.
This one.
You think that's what good scientists do. They test material to see if something's not working. They need to go back and repeat the steps and see what caused the problem or why is there an error. You draw your circuit. Now label your parts. What is this? Label the light. Good job. Nice. Now label it. Good job. Figuring it out. Good job. Draw your circuit. Draw your circuit. Did you label your parts? Battery, light. I only see two things. Battery, light. What else you need? Wires.
Can we put battery holder and then battery?
Just the battery. I just made it easier for you putting a. Now, is your circuit open or closed? Closed. Your circuit is closed because in order for that light bulb to come on, the circuit has to be closed. I see the lights on in the classroom. Is that an open circuit or a closed circuit?
Closed.
That's a closed circuit because the light is on in the classroom. If I turn the lights off in the classroom, open or closed circuit?
Open.
Good job. Say it again.
Open.
Open. That circuit is open when the lights are off. The circuit is open. Put the batteries in wrong?
Yeah, I think I just because I did that.
Let's see. Positive and a positive.
Yeah.
Negative and a negative.
That's what happened.
You think so?
Unless the electricity inside the light bulb blew out.
That's a good observation. Maybe the light is not working or maybe it's the battery. So which one are you going to figure out first? Which one to try to solve it? Change the battery. That's why Miss Carter put 2 batteries on your tray. See if it's the battery. It's on that plastic. Remember, it can't be on the plastic. All right, say now that you have drawn your circuit, whose paper? Whose paper? I don't know that. How do I know that? Yes, sir.
What if we put both of the batteries together?
No, we gotta. That's what we'll get a double. We'll get more energy by putting the batteries together. However, now we're gonna find out some information. We're gonna do some investigations. Touch the box at the bottom of your page. There are some items listed on your page. We're gonna find out and make predictions about whether these items would allow electricity to continue to flow through our circuit, or will it stop or slow down the electricity. If it allows the electricity to go through easily, what do we call those? Conductors. What if it stops or slows down the electricity? So I need you to make some predictions. Say that word with me. Prediction. What's a prediction? Raise your hand. What's a prediction, Mikhail? What you think is going to happen. So let's make predictions about each one of these items. Nail, make your prediction. Do you think it's a conductor or an insulator? Do you think the electricity will go through easily, or do you think it will stop or slow down the flow? So everybody in your group is going to have an opportunity to test an item. Here's your circuit. All right, make your predictions. Do you think a nail is going to be a conductor or an insulator? Do you think it'll allow the electricity or stop the electricity? Good job. Make a prediction. Predictions is what you think might happen. You're filling out each one. Good job thinking. You got to do all of them. Make a prediction for every one of them. If you just stop on the first one, you need to make a prediction for all of them. Make your prediction for all items on the sheet.